Welcome back to the next second lecture on data communication network. In this particular lecture, we are going to discuss about network. What is network exactly? Okay, so the network is nothing but interconnection of set of devices. Okay, and those devices capable of transmitting and receiving the data, as we discussed in the last class. Okay, so network is to connect a set of devices. Okay, it means through this network we can achieve the data communication. Okay, but when we talk about network, it has various components. The first component is known as host, or another name for host is known as end system. Okay, so end system is responsible for traffic source. It generate the data, it generate the traffic. Okay, or otherwise it also receives the data. Okay, so sender or source node, it can be the source, it may generate the data. I can receive the data. Okay, receive the device which is receiving the data is known as sync node. Okay, so host or end system can be the computer. It can be the desktop computer or laptop computer or workstation computer. As the host or end system can be the mobile. Okay, if you take just to consider this example here, this desktop computer is a host. Okay, it will transmit the data as well as it receives the data. Okay, these are the end system, transmitter or the sync node. Okay, or receiver. Okay, that is known as host or end system. Then the next element of a network is known as a device which connect the end system. Okay, the connecting device is known as switch or router. Okay, so we have two different type of connecting devices. One is known as switch, another one is known as router. Okay, so the both these devices, okay, router or switch. Okay, so both the devices are responsible for forwarding the data, and these two devices never generate the data. The responsibility is just to forward. What is forward? For example, if you take a switch, I have two input port and two output port. Whenever you get the data from any one of the output port, it forward the data to the whenever you get the data from one input port, it forward the data to the any one of the output port, depends upon the forwarding table. Okay, so here when we talk about switch, we have inbuilt fabrication, inbuilt structure. Okay, it can be the crossbar switch or batch banyan switch. Okay, so the crossbar switch or batch banyan switch, the each and every input port is connected with the appropriate output port. This internal component is in terms of wiring. Okay, so whenever the input port data is entered into this input port, automatically it will be forwarded to this output port. So from this output port, some other devices may be, and some other end system can be connected together. Okay, so this is a switch. Switch is responsible for just forwarding. It won't generate the data. Okay, it is neither the sender nor the receiver. It is capable of just forwarding the data. Okay, it select the appropriate outlink and forward the data. But another device, connecting device is known as a router. Okay, router is having an intelligence. Okay, whenever we talk about router, it also connected with more than one input port and output port. Okay, when it gets the data from this, for example, this is a router connected with four links. Let us assume this is link 1, link 2, link 3, and link 4. Okay, data enters into this link 1 through this link 1, and the data enter into the router through this link 1. Okay, so it can be forwarded to the link 2 or link 3, link 4, depends upon the destination address. Okay, so here it will make use of the forwarding table, forwarding intelligence. Okay, will be inside this. Based on the forwarding table, it will decide the appropriate outlink. Okay, so based on the appropriate, after selecting the appropriate outlink, it will forward the data to the appropriate outlink. Okay, so switch is a hardware, completely hardware, with the intelligence, with the software intelligence is known as router. Okay, actually we are going to discuss about the different layers. This is a layer 2 device and this is router is a layer 2 device. Okay, but both are actually connecting device. It is not it won't generate the data. It is responsible for connecting the end systems. Okay, And the third component of network is known as modem. Okay, so modem is known as modulator and demodulator. Okay, what is modulator and demodulator? When we talk about a modem, see, just I'm getting this picture clearly. You have a modem will will perform the task of modulation and demodulation. What is modulation? Modulation means analog to digital conversion. Demodulation means digital to analog conversion. Okay, so previously, and one way of connecting with the internet by using telecommunication network, existing telecommunication network carries only analog data. So analog to digital conversion and digital to analog conversion is required to transmit the digital data that is performed by use means of modem. That will change the representation of the data or form of the data. Okay, analog to digital conversion and digital to analog conversion. Okay, that process is known as modulation and demodulation. Okay, so in this case we have modem. Okay, where this is also a switch and this is also a switch, we have inbuilt in modem. Okay, and the medium which carries the data is known as a transmission medium. Okay, in this case this is actually a wired medium. This router is connected with this switch wired medium. This switch is also connected with four computers through the wire. Okay, this is also wired transmission medium, but we have also wireless transmission medium in which there will be the access point. Okay, for example, if you take a simple wireless communication, that will be the simple access point. Okay, in this access point, a number of mobile devices can be connected. Okay, so the mobile devices can transmit the data to the access point by using uplink frequency, and it will receive the data from the access point by using downlink frequency. Okay, so here in this case the medium of transmission is air. Okay, so as long as this data, the devices are in the coverage area of access point, can able to communicate with the access point by using uplink and downlink frequency. Okay, to take this here, end systems are routers, laptop devices, as well as access point. Access point is also receives the data, so access point is also end system, and the transmission medium here is a wireless transmission. Okay, there is no connecting devices here. There is no neither router nor the switch. Okay, no connecting devices. So this is an exact example for own architecture of network. Whenever we talk about network, that there is some systems known as end systems, and we need a device to connect. Okay, here in this case, I have four end systems, four computers connected with a switch. Okay, so this forms one connectivity one, and we have another four computer connected with a switch. Okay, this forms another connectivity. Okay, so this forms a connectivity two. Okay, now this switch is connected with the router. Okay, so this is a connectivity element 3. For example, if you consider a simple case, let us assume this is computer A, host A wants to communicate with the host C. Okay, so for that communication you can directly approach this switch and then hand over the data to the computer C. Okay, now this A wants to transmit the data to D. If it is so, A will hand over the data to the switch, and the switch will transmit the data to the router, and this router will transmit the data to this centralized switch, and this switch will hand over the data to this computer. Okay, so this sort of architecture is known as a network. Here I have shown only two different networks connected by using router, but in the real sense there will be a number of computers, a number of networks are connected together by using routers. Okay, so routers and switches are connected. Okay, so after discussing about network, we need to discuss about the way in which the connections are created. Okay, how the devices are connected. Okay, so when we talk about network, two or more devices are connected. Okay, by means of the link. Okay, so normally the link is the pathway through which the data travels. Okay, so we have classified the link into two types. Okay, one type of link is known as point-to-point link. Okay, another type of link is known as multi-drop link or multi-point link. Okay, so in the point-to-point link, a single link connects two devices, two endpoints. Two endpoints are connected with end system. This is end system one. Okay, and this is end system two. Okay, this is also end system. Two end systems are connected by using a dedicated line, a dedicated link. Okay, so this is known as a point-to-point link. Okay, but in point-to-point link, when we talk about this link is actually transmission medium. Okay, but if you consider we have 10 computers, each and every computer is connected with each other computer. Okay, if it is so, that type of connectivity is known as point-to-point connectivity. That means any computer can transmit the data to any other computer directly. Okay, that is a point-to-point. But nowadays we have billions and billions of devices are connected with the net. If we want to consider the point-to-point link, then the entire world will be flooded with wires. Okay, so its number of devices are limited. Then we can talk about point-to-point link. By number of devices are nowadays very high. Okay, initially before the invention of network, only two devices are connected, and those devices are connected by using a single cable, RS-232 cable. Okay, but nowadays we have number of devices, a number of end systems, even sensors, sensor nodes are number of sensor nodes are very high. Number of devices, mobile devices, laptops, computers are increasing exponential. Okay, so it's not possible to achieve point-to-point link and direct connectivity between each pair of system. That is not possible. Okay, and what is the solution? We have multi-point connectivity or multi-drop connectivity. Okay, so we have the common cable. The link is a common cable through which the devices are connected. Okay, so we have the tap here, this cable. Through this tap, the devices are connected. So the device A is connected with this tap, device B is connected with this tap, and device C is connected with this tap. At the same tap, mainframe server is also connected. So all the computers A, B, C can share the server, mainframe server. Okay, but in this case this end system is connected only with this end system. Okay, but in this case all three devices can share the common medium with the computer. Okay, so this connectivity is known as multi-point connectivity or multi-drop connectivity, through which a single cable is used to connect more than two computers. Okay, but here we have in the point-to-point connectivity, there is no problem of collision, there is no problem of congestion, there is no problem of delay and all those things. Okay, but this is utopian. It is not possible to achieve the point-to-point connection. We can achieve only the multi-point connection. When we talk about multi-point connection, see, a simple problem is that B and C at a time wants to receive the data from the mainframe computer or transmit the data to the mainframe computer. Okay, so if you transmit the data, for example, at the zero time, C is transmitting the data and B is also transmitting the data. So the data from C collide with the data from B. So none of the data will reach the receiver. Okay, so the collision is one problem. Here to solve the collision, we have to define some rules set in the protocol. Okay, so we have to set the order in which the data to be transmitted. Okay, so for example, at time t0 time, if we started transmitting the data, then C should keep silence. Okay, so by using the protocol, we can have the control over all these devices. The devices can be controlled by using set of rules or protocols. Okay, so this connectivity is known as multi-point connectivity, and the previous connectivity is known as point-to-point connectivity. Okay, so the computers can be connected by using either point-to-point connectivity or multi-point connectivity. Okay, so after discussing about the multi-point and point-to-point connectivity, let us see the topology. Okay, topology. What do you mean by topology? Topology is a representation, geometric representation of the relationship of the various links. Okay, as well as the devices. Usually, there are some common topologies are available. The common topologies are listed here. The first topology is known as a ring topology. Okay, so the ring topology, if you take ring topology, like we take, I have a device A and device B, C, D, E, F. Okay, and to connect these number of devices, that means I have six devices to connect six devices. I need six links. Okay, but in the ring topology, the direction of transmission is in one direction, either clockwise direction or anti-clockwise direction. Then let me put it in the right sense. For example, A wants to transmit the data to C. Okay, let us assume a clockwise direction of communication. A will transmit the data to B first, and the B will forward the data. Not transmit. B will forward the data to C. So similarly, A wants to transmit the data to F. Okay, now in this case also, it won't allow two directional communication. A will hand over the data to B, B will hand over the data to C, C in turn D will transmit the data to E as well, and then E will hand over the data to F. Okay, so this type of connectivity is known as ring. Okay, one common or well-known ring topology is known as IBM token ring topology. Okay, Ethernet standard IEEE 802.5 token ring. Okay, so the token ring, for example, A wants to transmit the data to C, then A will have that. A should, because in this case also two devices cannot transmit the data at the same time. Okay, so if A wants to transmit the data, A should have the token. Okay, after transmitting the data, it will hand over the data token to the neighbor. Okay, so if B wants to transmit the data, then B will retain the token and will hand over the data to the neighbor, and then after that it will hand over the token to the neighbor. So if has nothing to transmit, then simply hand over the token to the neighboring node. Okay, token will travel in the again the clockwise direction. Okay, so this topological structure is known as ring topology. Okay, and another common topology is known as line topology. Here also we have six nodes A, B, C, D, E, F. Okay, six hosts are connected by using a common bus. Okay, common link. Okay, so if A wants to communicate with the C, A can transmit only through B. Okay, A will hand over the data to B, B will forward the data to C. Similarly, A can communicate with F through these intermediate devices. Okay, so the direction of communication here, it will occur in both directions. A can transmit the data to B as well as B can transmit the data back to A. Okay, so this is known as a line topology. And similar to line topology, we have a bus topology. In the bus topology, we have common bus that there is a taps there, and devices are connected through that tap. Okay, so similar with the line topology. In line topology, the link is connected with the device. The device will receive the data and then forward the data. But here, in this case, for example, A wants to transmit the data to F. Okay, so the packet or the data will be the payload, the information added with a header. The header includes the destination address. Okay, here the destination address is F. Okay, so A will just inject the data with the destination address F. Okay, so now the data travel in this direction. Now this computer also will see the data, but it will check the destination address, but destination address is not his address, so that it's address, so that it simply forward the packet. Okay, it simply neglect the data, it won't forward. Okay, so the data still travel in the same direction. Now the F will receive the data because it's the packet includes receiver address. F address is a destination address. Okay, so this architecture is known as bus architecture. In the bus architecture also, two computers cannot transmit the data at the same time. If I try to transmit the data at the same time, then both the data will collide with each other. Okay, so if it collides, then none of the packet will reach the destination. Okay, so that is a bus architecture. It's a common standard for local area network. This is known as 802.IEEE. IEEE is a standardization. Okay, standardization body. IEEE 802.3 local area network. Ethernet is a standard. Ethernet is a standard for constructing the LAN network. Okay, And we have tree topology. In the tree topology, we have the root node. Okay, so in the root node, the first level node are directly connected with the root node. Second level nodes are connected with the first level node. Okay, in this case, for example, let me take this is A and this is B and this is C. Okay, only these devices will be the end systems. Okay. So if A wants to send something to B, A will hand over the data to this connected device. This connected device will transmit back the data to B. Okay. But if A wants to transmit the data to C, A will transmit the data to this connecting device, and then this connected device will hand over the data to the root node, and this root node will forward the data to this node, and then it will reach. Okay, so only the leaf nodes will be the end system, non-leaf node will be the connecting devices. Okay, then we have fully connected topology. The fully connected topology, we have 6 nodes, each node is connected with each other. Okay, for example, here A is connected with the, okay, let me take the B, C, D, E, F. Okay, A is connected with the B directly with this thing. A is connected with the C. A is also connected with the D. A is also connected with the E. A is also connected with F. Okay, if it is a duplex, full duplex link, F is also connected with the A. F is also connected with the B. F is also connected with the C also. Okay, but in this case, number of links required to construct a fully connected networks is very high. Okay, for example, if you have n number of systems, we need n into n plus 1 by 2 connectivity links. Okay, so number of links required to construct a fully connected topology is very high. Number of nodes are increased, then automatically number of links to connect to construct the fully connected topology will also be increased. Okay. The next structure is known as star architecture, star type structure. Okay, there will be the central node. Okay, all the devices are connected with the central node. For example, if any one of the node is A and this is B, if A wants to communicate with the B, A will hand over the data to the central node, and central node will hand over the data to the destination. This type of architecture is known as star type architecture. And finally, irregular architecture is known as mesh. Okay, so the fully connected is also known as mesh. Okay, so this is irregular. The computers are connected by using a different structure and different links. Okay, so this is mesh like architecture. All these are different type of connectivity model which provides a different. Okay, welcome back to the second lecture on data communication network. Now, in this particular lesson, we are going to discuss about different types of network. We can classify the network into different, broadly, we can classify the network into different types like telecommunication network or internet, intranet. But based on the size or geographical coverage area, we can classify the network into various categories like personal area network, local area network, and wide area network. Okay, so what is personal area network? So personal area network, it covers a very small distance within a home or within a room. Okay, so this personal area network is a privately owned network. Okay, personal area network is a privately owned network by the private person, and it connects a computer or system or devices inside the same room. Okay, so this is one pictorial representation of personal area network. We have the desktop computer and digital camera, a fax machine, and the mobile phone. All these devices are connected together. Okay, so from the computer we can send some data to the fax machine, and digital camera transmit the signal to the computer. Okay, so all these devices are inside the same room or simply top of the table. Okay, so it covers a small area, and the transmission medium here is the air. Okay, so it can be simple radio waves. The signals are transmitted in terms of transmitted through the transmission medium and backup. Okay, or air. Okay, So in this particular case, these devices can communicate with each other. Okay, so when you talk about posterior network, the number of devices which are connected is limited, as well as the distance, the coverage of the distance is also very limited in terms of meters, okay, centimeters to meters. Okay, so this is one example, but when we talk about a real example or application of posterior network, it's like a body area network. Okay, it's known as a body. One example of a posterior network is body area network, medical body area network. Okay, so in medical body area network, a person injected with a implantable devices. For example, a sensor, ECG sensor, okay, and blood pressure sensor. Okay, so all those sensor nodes are planted. Okay, so those sensor generates the data. So that data will be transmitted to the PDA, personal digital assistant, PDA. Okay, personal digital assistant. So the data transmitted to the personal digital assistant through the wireless medium. A ZigBee protocol, radio communication. Short range radio communication to transmit the keep on transmitting the data to the personal digital assistant. Okay, so this is one application of personal area network. Okay, so the personal area network, it covers a limited geographical distance, and it covers limited devices. Okay, the next broader category is known as local area network. Okay, so we talk about local area network. The distance covered by local area network is something large. Okay, inside a building. Okay, or inside. So let me talk about the local area network. The local area network, it covers somewhat larger geographical area. So it's also privately owned network. Okay, privately owned network. Okay, I connect the computer inside the building or inside the campus or in the organization. Okay, so normally the older version of a LAN network is based on the is common cable like this. Okay, so that will be the common cable, and all the that will be the tap inside the table. Host or printers, the devices are connected with a common cable. Okay, so this is a tap through which the devices are connected together. The purpose of this LAN network is the resource sharing of resource. Okay, maybe one host may be the printer, one device may be the printer. All the hosts can share the common printer. Okay, so that is the tap through which the computers are connected together. This is a old version. Okay, but now we need high speed LAN network. For high speed LAN network is based on switch. Okay, so there is a switch or hub through which the hosts are connected directly. Okay, so this type of LAN network is today's high speed local area network, or otherwise it is known as switched local area network. Okay, so here in this case it is a switch. Okay, so here this is a tap through which the cables are connected, the computers are connected together, a cable with the open tap. Okay, so now here in this case a switch is connected with the host is connected with a switch through common switch. Okay, so local area network, the capacity, the channel capacity is in terms of Gbps. Okay, fiber, if the fiber cable is used, can transmit and receive the data in terms of Gbps, but personal area network can transmit and receive the data in terms of kbps. Okay, and the next broader category is known as wide area. Okay, so wide area network, we have two different type of wide area network. One is known as point to point network, another one is switched wide area network. Okay, normally wide area network covers a large geographical distance. Okay, large geographical. For example, it covers the computers which are inside the same town or the state or in the country. Okay, in the point-to-point wide area network, there is a channel, a separate channel that connects two nodes. Okay, but normally two computers won't be connected together like this. In the telecommunication network, we have a toll office, inter-toll office. Okay, the inter-toll office directly can be directly connected by using high capacity channel. Okay, the capacity of the channel in terms of gbps, gigabits per second to terabits per second. Okay, can transmit the data at this particular speed. But this switch can be connected with the entire local area network. So all the traffic from this network, okay, to this network is through these two switches. Okay, these two devices. Okay, and these two devices are directly connected by using a high capacity transmission medium, high speed transmission medium. Okay, so this is actually a point to point wide area network, but in all the cases point to point wide area network may not be possible because point to point wide area network is somewhat costly to construct. So that we have multiplexed type wide area network, that is known as switched wide area network. In the switched wide area network, we have the switches. Okay, let us assume we have switch A, B, C and D. Okay, so now here from this network is, let us assume this is connected with a network 1. Okay, and this is network 2. Okay, communication from network 1 to network 2 can happen in different way. Okay, one is communication may be transmitted to this node. Okay, and this switch can transmit the data to this. Okay, this is one path. Okay, let it be, this is the first path. Similarly, the destination node is the destination network is N2. Okay, there is another way to reach this also. So A can transmit the data to B, and then B can transmit the data to D. Okay, so this is known as path 2. Second path. Okay, so in this switched local area network, the channel is shared by more than one network. Okay, why? See here, this particular channel, all the traffic from A to D will follow this. Okay, all the traffic from C to D will also follow this. Okay, so similarly, this channel is also multiplexed common channel. Okay, so the traffic from more than one network can follow the same channel. Okay, this is something different from point to point. In the point to point data, to reach this destination, no other option. Okay, only this transmission link to be used. But here, to reach this destination, we have two options. One is this direction, another one is this direction. Okay, so this is a kind of switched network, switched wide area network through which we can connect more than one network type. Okay, in this case we have connected only two networks, but in this switched wide area network we have connected four. Totally, actually, we have 4, 5, 6, 7, 8 networks are connected together. Okay, so this is a use of a wide